Good afternoon, everyone. On behalf of AOG, I would like to welcome you on webinar series and that we do every Wednesday. As you know, AOG is serving to the Oracle community, and every Wednesday we are conducting webinar series, and that is a learning opportunity for you, everyone. So, little housekeeping rules here. Use Q&A section for your queries and use chat section for any help required during a session. And you can continue networking on Twitter with the speakers and participants. And this presentation material we will share on the AIG website. So after this session, you will get the survey link, and please do the survey and give your feedback about the sessions, and that will really help us to bring more and more content to you in this webinar series. Today we have a very great speaker, Veera. Many of you might know Veera. Veera is a Golden Gate master. Veera has a very vast experience in the cloud database migration and in architecting solution of many heterogeneous replications around the different databases. So he is an Oracle certified professional and Oracle Golden Gate certified implementation specialist. So Veera is one of the co-founder of AIOG Chennai chapter, and he leads the AIOG Chennai and Bangalore chapter. He is many his contribution to the AIG community is really very, you can say, encouraging to all of us. And also I would like to say that he also as director, and also he is running his blog on oraclescn.com. So he is a wonderful personality, and he's a master of Oracle Golden Gate. So uh, let's learn together for the Oracle Golden Gate, and we can have many more sessions from Veera in coming the webinar series. So thank you, Veera, for joining us and sharing your knowledge with us. You can start sharing your screen and start presentation with you.
Thanks, Chandan. It's audible, right?
Yes, Veera, it's
Okay.
audible. Yeah.
Thank you, Chandan and AOAG, for providing me this opportunity. This is my first session in 2021, right? So just now the year has started. So thanks a lot for that. I have a introduction slide of mine. I think so. I don't want to put that one. Put that one. You already told many things about me.
Veera, can you share your screen? We
Yeah,
are not able to see.
yeah, yes. I'm just sharing it. So you can see my screen, right? The presentation screen.
Yes, Veera. Yeah.
Okay. Yeah. Thanks for the intro, Chandan and AOG team. And so let's start with the session. And today I have more slides to present. So more and more information to present on the CDR, right? Conflict detection and resolution. So before that, very happy New Year 2021 for the one-on-one present virtually in this conference. Thanks for spending your time and attending my session today. Let's move on. As I told you, I don't want an introduction. I think already Chandan has told many things about me. I work for Fidelity Investments as a principal database administrator, and this is my LinkedIn URL and tweet handle. I continuously write blogs, articles about Oracle Golden Gate, and oracle-scn.com is my website. And I love to contribute in forums. Hope everyone knows about Oracle forums, right? OTN forums. Initially we call it as now it is groundbreakers. So people around the world ask many questions. There are different sections. Like for data guard, it will be different. For Golden Gate, it will be different. For RAG, it will be different. So similarly for Golden Gate, I used to continuously reply for all the queries whoever posts queries in the forums across the world. And that is about me. I don't want to spend more time here. Here, let's start with the architecture, right? Going on with the architecture, I will be talking about different topologies of Oracle Golden Gate, and from there we'll be moving on to the CDR part. What is conflicts? What is conflict management? How to handle conflicts? And what is CDR? What are all the prerequisites or requirements need to configure CDR? And later on, we will move on to our the original topic, right? Auto CDR and comparison of CDR, the manual CDR and auto CDR, and then the advantages, I mean the pros and cons of the auto CDR. Everything I will be telling in this session. I try to cover maximum of the thing in this session, but a few might be left out. If I get a chance again, definitely I will have a part 2 for this. So let's start with the architecture. Okay, the graphic which you see in the screen, right? That's my initial slide. From the day one I started presentation, I used to have the first slide as this one only. So this is the simple way of representing the Oracle Golden Gate architecture. We have source and target. Golden Gate is a replication tool, and it's a heterogeneous replication tool. That's outstanding one when comparing to all other replication tools available in the market, right? So we have source and target, and in the source and both the source and target we have manager process. Manager is a process which will be handling or monitoring all the sub processes running in the Golden Gate instances. So extract will be running in the source. Extract is nothing but the capture process, which will be capturing the committed transactions, right? It captures only the committed transactions from the read log or RK log and writes it to the trial file, which will be residing in your local system, file system. So we call it as local trials or extract trials. So from the extract trials, whatever changes that has been written by the extract process, the data pump process reads those changes and it will pump. That's the name, right? Data pump. It reads the data and pumps the data to the target. And in the target, you have collector process. The collector is nothing but receiver. It receives the data or collects the data, whatever has been transferred or pumped by the data pump process over the TCP network, receives the changes and writes it to the trial file, which resides in the target database, target file system, we can say. So we can say the trial files which resides in the target as target trials or remote trials. And from the remote trials, the replicate reads those changes and converts the changes. So Golden Gate writes in its own canonical format, and it reads the data and converts the data into the SQL statement and applies the data to the target database. This is the simple way of representing the Oracle Golden Gate architecture. Moving on to, we have different topologies available. So Oracle Golden Gate is very flexible in nature. We can replicate in many ways. So you can see one-to-one, right? One-to-one is nothing but one source and one target, and bidirectional. It means like active-active. It is not a kind of exactly similar to the RAC, real application clusters, but somewhat okay. Like the application will be connected on both the sides, and the data will be replicating A to B and B to A, vice versa. So that is bidirectional. One-to-many, we have one source and multiple target. That is nothing but broadcasting your data from one source to multiple target databases. And next one is many-to-one. Many-to-one is like consolidating the data. So getting the data from multiple source and consolidating the data to one single target. We say it as consolidation. This is many-to-one. And the next topology is cascading, right? We have physical standby databases. We have physical cascading standby databases, right? So if we have 4 target or 3 target standby databases, it's not necessary like we need to transfer or move the data from primary database to all the 3 standby databases. So instead of that, what we can do is we can replicate or move the data from primary database to first physical standby database, and from there we can again cascade the data to other standby databases. So that is also available in Golden Gate. And peer-to-peer, we call it as a multi-master replication, right? If you have one source and one target with both the ways the replication is happening, that is called bidirectional. Wherein if you have multiple sources and targets, multiple databases, and the data is flowing across all the systems like a cyclic way, we call it as peer-to-peer or multitasking, multi-master replication. So today, we are going to mainly concentrate on the bidirectional, multi-master replication or bidirectional or many-to-one. So let's see what exactly happens, what additionally we need for these configurations to work, right? So if it is one-to-one, that's nothing, like only one source and one target. It's a direct replication. So data will be captured in the source and that will be replicated to the target. But there is something special in the bidirectional replication. As I told you, bidirectional replication, excuse me, we have both the applications connecting to the both the sites, both the databases, and it will be keep on doing all the DML operations, right? So the data will be flowing from site A to site B, and again vice versa from site B to site A. That we call it as bidirectional active. We also have active passive, but today we are going to talk about active only. So what is special about these configurations, right? As I told you, unidirectional is it's a straightforward replication. One source, one target. We are going to replicate. The data is going to flow only from left to right, right, from source to target. But in bidirectional, the data is going to flow on both the sides, and even in peer-to-peer or multi-master replication. And you may have a question: why? What is a additional requirement for many to one consolidation, right? So suppose I want to replicate same table which is residing in database 1 as well as database 2 to the target. I have employee table in site 1, and I have employee table in site 2, and again I have employee table in site 3. So I want to replicate the employee table from site 1 and site 2 to site 3. So that is something we need to maintain. Right? Suppose a couple of same DML operations on the same row. If it comes from site 1 and site 2, which one will be succeeding? So that is something special, right? Here. So let's look what is special here. Conflicts. Obviously, I told you, right? So if both the rows are getting updated in the same time on multiple sites, conflicts occur, right? So that is what conflict. So my application is connected to both the sites, and it is a bidirectional replication. And there is an update statement coming from the source where employee ID is equal to 100, right? Employee ID equal to 100, and the same row is getting updated in parallel on the target side as well. So in one side, my salary, the salary of the employee whose ID is 100, right? Employee ID is 100 is updated to 10,000. Wherein the other side, in the target side, the same row is getting updated to 15,000. So which row succeeds? Which record succeeds here? Either the record which is coming from source or the record which is coming from the target. How to handle this? How to handle such kind of conflicts? We can use handle collisions or insert missing updates or rep error, but that is not advised, you know. So even usage of handle collision itself is not advised. If you are using it, you see a car, right, blue color car, which is going upside. That is how happens for our data as well, or in the database. So it leads to data integrity issues. It is not advised in such scenarios. It is not advised to use either handle collisions or insert missing updates or rep error. These are all not advised or recommended parameters to use in the replication environments. So it has a specific standard or a specific logic, or in specific scenario we can use these parameters, but not in the bidirectional replication. And this will be the pretty decent way, right? CDR, which has been introduced by Oracle. We call it as conflict detection and resolution. So this is what we are going to see today. So when and where the conflicts happen. As I told you, when we have a bidirectional replication, active, that to active bidirectional replication, there are not many of chances for the conflicts to happen. And as I told you, the second one is the multi-master replication. And thirdly, like when a row gets updated or modified in more than one site in parallel, right? So I told you, right, if the same row is getting updated on both the sites, so then that will be an issue. That's a conflict, right? So these are the three types wherein conflict arises. So how to manage conflict? Suppose I have a table, employee in the source, and in the same table in the target as well. And as I told you, the same row whose employee ID is 100, right, is getting updated. So what is needed to resolve the conflict? That is what we told, right? So which record succeeds? That was our question. This is a conflict, and we need to know which record to succeed, right? So what is needed to resolve this conflict? That is something we need to resolve the conflict. That there is some key parameter or some logic behind this to resolve the conflict, right? So what is that? Timestamp. For example, let's take a 100-meter race, right? Like how the winner is being decided. It is based on the time, right? A guy who completes a 100-meter race within in 20 seconds, and another guy who runs the same race and he completes in 18 seconds. So who will be the winner? Obviously the least time, right? 18 seconds. So the time plays a major role here. So to resolve the conflict in CDR, we need a timestamp column mandatorily. So for any table for which you are going to configure the CDR, like in bidirectional replication, right? The conflict detection and resolution, those tables must have a timestamp column. So without the timestamp column, you cannot, you cannot go ahead and resolve the conflict. CDR cannot resolve the conflict. So for any table which are configured for bidirectional replication, you need timestamp column. Okay. So moving on, so what are the data types that are supported for the CDR? So numeric data types are supported, the date columns are supported, timestamp columns are supported, the char and nchar, varchar and invarchar. These are the columns that are supported. Supported in the sense these are the columns can be compared. Okay, so when you want to resolve the conflict, right, we need to compare the data which is coming from the source. Unless and until you compare the data, you cannot resolve the conflict. That is a pretty basic thing, and the logic which works behind the conflict detection and resolution. You can see in the below, you see many parameters like here, get before calls and compare calls, use min, use max, resolve conflict. Don't worry about those things. In the later slides, I'll be explaining each and every parameter and what is the usage of it. And in these parameter compare calls, for example, we'll be comparing the before image and the after image, right? So the before image of the columns, the record has the before image and it has the column values, right? So which columns are, what are all the columns supported? So these are the columns, numeric columns, date columns. These are the type of columns which are supported for the comparison to detect the conflict and resolve it. So there are some prerequisites, requirements to configure the conflict detection and resolution. It's nothing but CDR. Okay, so let's see what are those. We need a before image and the after image of the record. So what is before and after image? We will see it. And you all know about sequences, right? If it is a unidirectional replication, then we don't want to worry about the sequences at all. But when it is a multi-master replication or bidirectional replication, definitely we need to take care of the sequences, or else it will be a very big trouble for our replication environment. And you also need to set few parameters. So these parameters will invoke or will make the CDR to work. Right? We need to set few parameters on the extract side as well as on the replicate side. So log all subcalls is a parameter we need to set in the extract parameter file. Get before calls is a parameter which we will be setting in the extract parameter file. Similarly, tran log options exclude tag. We also have one more option, exclude user. And in the replicate side, similar to the extract parameter file, we need to add many parameters like repair, compare calls, resolve conflict, DB options, set tags. And there is one more additional thing which is called exception table, right? That's pretty new thing here for the CDR. That's pretty new thing for the CDR. So let's see one by one what these things are. And thanks, Sai, for allowing me to have your image here. So this is a classic example of before and after image, right? So if someone is new seeing Sai, right, in this, or if someone sees Sai after a long time, so they couldn't able to recognize, right? So we need a before image to recognize whether to match the image, right? So is it Sai or someone else? So definitely it is Sai. We all know them. We all know him. But we need some before image, right? Before Sai was like this, after Sai was like this. If in any verification report also, right? They need the before image to compare, is it a correct data or not, right? So we call it as before image and after image. Before and after image are needed for the CDR to compare it. Okay, it compares the before image which comes from the source with the current image in the target table, and then it detects the conflict and then it resolves. That is how it happens. So for example, let's take an employee table here, and you can see the salary, it's 1,000, and in the after image it is 1,500, and you can even see the change in the timestamp. And this is the before image, and this is the after image. We need to have a complete before image and complete after image to enable in order for the CDR to work efficiently. So it's not it's not pretty mandatory, we say, but it's a recommended way to have all the column images in the before and after. So this is the command add tran data source.employee is my table, and all calls is the option wherein all the columns will be logged in to the redo log, right? So what happens if I don't specify this all calls, and when I execute this add tran data behind the scene, it means like at the back end of the database, right? In the database, alter table add supplemental log, that is a command which will be executed when I trigger this add tran data command. So if I didn't specify the option all calls, what happens is by default, whenever a modification happens to a row or a record, what happens, only the modified column along with the primary key column will be captured in the redo log. I'm saying in the database redo log. Okay. So, but this is not a full image, right? We have only modified column and the primary key column. So for in order for the CDR to work more efficiently, we need this complete before and after image. So we use all calls. So all the column values are logged to the redo log, irrespective of the changed column. It means whatever columns may have changed, may get modified. Irrespective of the changed or modified column, all the column values are captured and returned to the redo log file. For that, we need all calls. And here, one point I need to say is like definitely it will be a overhead because it depends on the columns, number of columns present in the table, and the size of the column, we can say. So there will be more redo generating in your database, but we need to sacrifice something in order to get something, right? So if you want the CDR to more efficiently work, then definitely you should capture all the columns of the record. So this is a must. You need to add the trend data with all the columns. So next is the sequences. So sequences, how to handle sequences in a bidirectional replication. So in one site, in site A, I can increment the sequence value by odd number, right? Like 1, 3, 5, 7, 9, something like that. And in the target site, I can increment the sequence value, the next value, by using like a even number, like 2, 4, 6, 8. So there will be, when you do this kind of logic in a bidirectional replication, we can avoid conflicts in the sequences. And what happens in the multi-master replication when you have multi-sites having a similar kind of bidirectional replication, right? So what we can do is, for example, we have site 1, site 2, and site 3. So we can increment the next value of the sequence, right? Site number plus 3. For example, 1 plus 3. Site 1 is 1 plus 3. Site 2 is 2 plus 3, and 3 plus 3, likewise. So if we follow such kind of logics, we can easily avoid the conflicts happening in the sequences. The next requirement is the extract parameters. So what are all the parameters we have? Log all subcalls. Log all subcalls is a parameter which needs to be added in the extract process parameter file. It automatically includes or captures the before image of the record. Whenever there is an update or delete operations happening in the database, it automatically captures the data, the before image of the data, and writes it to the trial file. The trial log options exclude tag and exclude user. Exclude tag majorly used in the when you use integrated capture, and exclude user, yeah, you can use it in the classic capture. What happens to avoid loop back? What happens is like, for example, in a bidirectional replication, I am updating this. Let's take the same example, right? I'm updating a row where employee ID is equal to 100, and I'm updating his salary from 5,000 to 10,000. That goes to the target, right? In the source, it gets committed. That goes to the target, and we see no conflicts. It's a very pretty simple update. And what happens? That row gets applied, right? That update statement gets applied to the target side. Once it gets applied to the target side, what happens? Again, the changed column, modified column, along with the additional columns, right? All the columns of the table will be logged in the redo log. So what extract thinks is, okay, there is some change in the data, so we need to capture that data, and it again captures the same record and again pushes to the source. So this is kind of a loop, right? So when this happens, right, your process will get will be hung. Actually, it will be keep on in the loop. So to avoid that loop, what we need to do is we need to set a tag, exclude tag. By default, like replicate applies the transaction in tag 00. So in the replicate parameter file, you need to set a tag, like db options is a parameter, db options set tag O. And in the capture side, we need to set a tag like tag log options exclude tag OO, that is 0000. So what happens when this extract sees a transaction or an operation, DML operation or a record with the tag 00, it automatically avoids it. It will not capture, actually. It ignores that particular row which has the tag 00. So in this way, what happens? The loop will be we can overcome the loop back, right, in the bidirectional replication. So that is the reason why we use tag log options exclude tag or exclude user. GG admin is nothing but replicate by default applies the transaction with the GG admin user. So either it is GG admin or GG ADM or GG whatever the golden gate administrator user you're using in the database. What with that particular user, the replicate process will apply the transaction in the target side. So once you give this parameter tag log options exclude user GG admin in the extract side, whatever transactions being applied in the target by this particular user will not be captured by the extract. So by this we can avoid the loopback in a bidirectional replication. The last one is get before calls. It captures the before image of the columns which we specify for an update or delete operations and writes it to the trial files. And you can see the below parameter, the table and the table name, get before calls, on update all, and on delete all. So whenever there is an update or whenever there is a delete, the before image of the row will be captured. What are the before image it will be capturing? It will capture all the column values, right? Because we are giving on update all. It means it captures by default, it captures all the row values, all the column values of the record, and it will write to the trial file. That is the reason why we use here get before calls. So the next one is replicate requirements, the parameters which we use for the replicate side. So rep error is nothing but by default in any error when the replicate encounters any error in the target side, by default it gets abandoned, right? It errors out. The process will not run. That is by default. But we can handle these errors in multiple ways. So we will talk about that. And the next one is compare calls. Compare calls is nothing but this parameter it compares the before image, whichever comes in the trial file, right? In the trial file, all the operations, whatever happens, right? The extract will be writing in the trial file. So since we are capturing the before image as well as the after image, there will be before image, after image, before image, after image. If there is an update, the update operations has two records kind of entries. One is the before image, the other one is the after image. So likewise, whatever the before image comes from the source trial file, that before image will be compared with the current image of the target table record. So whatever the record has the current value, current image, right? With that image, the before image will be compared, and the conflict is detected when there is an update or delete operations. So that is the reason why we use compare calls. Okay, now we use compare calls. So what is next? It detected a conflict. So what is next? We need to resolve that conflict. How do we going to handle the conflicts? So how we are going to resolve the conflicts? There are many methods of resolving the conflicts. For example, if you see in the below syntax, right, we have map, source, and target. Compare calls is a parameter, as I told you, on update all, on delete all. It means it compares each and every image of the column, of the before image of the column with the current image of the target table record. Okay, that is the reason why on update all, in the sense all the column values. So next one is the resolve conflict. What is resolve conflict? Insert row exists, default use max of change timestamp. It means insert when a row, I'm inserting a row in the source, the same row existing in the target. So what should be done? So use max is another option wherein it uses the maximum timestamp. Whichever record has the maximum timestamp, it wins. So we will talk about that in upcoming slides. So these are all the pretty basic parameters which are required to enable the CDR, for working of the CDR, right? Conflict detection and resolution. So exception table, this is something additional for the CDR configuration. So, before going to the exception table, we need to understand how we can handle the error in multiple ways. I told you, right? Rep error, by default, the replicate abundance. Whenever the replicate process encounters an error, by default it abundance. But what happens? We don't want to make the replicate abundant, right? We have multiple other options for the replicate on how to behave whenever an error is faced. So nothing but rep error. Rep error is the parameter. So use the rep error parameter to control how the replicate responds to any error message, any error encountered by the replicate process. So how to handling the error in the rep error? We have 4 types. The one is abandon, that is by default. Whenever an error is encountered, the replicate abandons. The second one is discard. We have a discard file, right? You guys know what is discard file. So whenever there is an error happening in the target side, the replicate, whenever it happens, right, the problematic record will be returned to the discard file. We have by default it will be done. So that is discard. And the third one is exception. So this is what another one. We have exception table, wherein the problematic record will be returned to the exception table. And ignore. That is the fourth option. So let's see one by one. Abandon. Abandon is nothing but suppose the replicate is processing a transaction of say 5,000 DMLs, DML operations, and it has completed processing in one single commit. Okay, one single commit, we have 5,000 DML operations. It's a one single transaction, right? So it was processing the transaction, and it has processed around 2,000 records, 2,000 DML operations. Okay, and when it comes to 2001, there was an error and replicate abandons. What a replicate does is it completely rolls back the transaction and it will abandon. It will stop. So abund is nothing but abnormal, end is called abund. So that is abund by default. Discard, as I told you, when that happens, right, in which record the replicate abandoned, right, or if the which is a problematic record. So 2500 DML operations has been completed. The 2501, that with that DML operation there was an issue and the replicate got abandoned. So that particular DML operation will be DML, or the record will be written to the discard file, and the replicate will not abandon here. Actually, when you use discard, it will continue processing the 2500 second. From there, it will continue processing the other records. And exception, instead of logging into the discard file, what happens is it logs the or inserts the problematic record to a separate table, which we call it as exception table, and it starts continuing the process. Only that particular problematic record will not be processed by the replicate. Other records will be processed by the replicate process. The last one is ignore. We should never use this option actually. So ignore is nothing but just ignoring the errors, right? Whatever error is faced by the replicate process, replicate never bothers about it. It simply ignores that error and it will start continuing the other records to process. So if we use this kind of parameter, right, option, ignore, for repairer, ignore, for example, repairer 1403. 1403 represents no data found, and I give ignore. So whenever 1403 is encountered by the replicate process, right, it will never log the information to the discard file or the exception table. It simply ignores the error and it moves forward. That is the ignore. But we will never come to know, was there an error faced by the replicate process, or is there any other is the data, or the data between the source and target are same? We will never come to know when we use this ignore option. So today we are going to see about exception table, which is needed for the very much needed for the CDR, conflict detection and resolution. And exception table, we have two kinds. One is dedicated exception table and global exception table. So what is dedicated exception table? For example, if I am configuring CDR, conflict detection and resolution, for employee table, for that particular table, I will be having a dedicated exception table. So that is called dedicated exception table. So each table configured for replication will have a dedicated exception table. That is called dedicated exception table, wherein only one exception table for a schema, for example. Excuse me. So only one exception table for a schema. Suppose I have a schema called excuse me, HR. Suppose I have a schema called HR, and we'll be having only one exception table for the particular schema. So what are all tables having present in the HR schema? All the tables will be pointing out to only this particular exception table. That is called global exception table. The exception in the dedicated exception table, the exception table will have the information of the replicated table columns. So whatever row is getting replicated, right, even those columns also will be there along with the additional columns like commit timestamp, from which source the data has come, which user has triggered this statement. All those informations will be stored in the exception table. So along with that, we can even capture the original values. I mean the before and after image of the record, which is coming in the from the source to target. But in the global exception table, since it represents all the tables of one particular schema, we cannot have the table information, right? So we can have only the transaction information, like what kind of transaction it is, from which source it came, what is the commit timestamp, those kind of information will be present in the exception table, but not the real column data, right? The real record data, we cannot see it in the global exception table. For example, I have a HR schema, I have employee table, salary table, and department table, but you can see there will be a dedicated exception table for each and every table present in the HR schema, right? But it's not the case with the global exception table. So for all the tables which are present in the HR schema, there will be only one exception table, which is nothing but HR.expns. That is the exception table name. Exceptions, for example. Okay. And this is how the dedicated exception table and global exception table looks like. This is the description of the table, and I will show you the difference. What the difference is in the dedicated, you can see, right? I have the column values as well, right? The employee table has employee ID, employee name, department name, salary, and country. These are the columns which are present in the employee table. Along with it, I have the transaction information as well, like what is the sequence ID, what is the host name, DML type. You see what from which instance it has come. So what is the DB? If there is any error, what is the error? What is the commit timestamp? All the information along with the table values, table column values will be present in the dedicated exception table. Wherein in the global exception table, you cannot see that. You cannot see that, right? Only the transaction information will be present in the global exception table. So that is what replicated table columns are present in the dedicated, whereas no replicated table columns are present in the global exception table. So for the pros and cons, left hand side we have dedicated exception table, transaction details with before and after image of problematic record is present. But whereas in the global exception, that's not there. Only the information of the transaction will be present in the global exception table. And when we see the advantage of global exception table, now the heading has changed. Initially, it was exception dedicated here in the left hand side. Now it is global in the left hand side. The advantage of global exception table is less maintenance, right? So whenever we add a table to a schema or drop a table to a schema, I don't want to additionally do anything in the exception table, right? Because I have only one single table for the entire schema. So that is, we have very less maintenance on that. When comparing to the dedicated exception table, whenever I add a table to a replication or remove a table from the replication, I'll be creating additionally an exception table for that particular base table or the application table, right? So if I add an employee table to the replication, I need to create a separate dedicated exception table for the employee table. So after some time, I want to remove the table from the replication. So obviously, I need to remove the exception table as well. That is an additional overhead. That's some additional maintenance needed for the dedicated exception table. So it is us who need to decide which kind of exception table we need. Okay, if we are going to use the global exception table, then where do I see the record information, right? I cannot see the table column data. So where do I see that? In the discard file, right? That is the reason why we have a discard file. Right, in the discard file, you have the before image as well as the after image. Both the data are present in the discard file. So these are the basic conflicts handled by the CDR. We have three types of operations, DML operations. One is insert, and second one is update and delete. And for insert, obviously we know, yes, uniqueness of the record, right? Unique constraint error, that is what insert conflict is. And for the update, when I'm updating a record and that record does not exist in the target, that is a conflict. And I'm updating a record and the record exists in the target, but the before image and the current image of the record is different. That is another conflict. And similarly for the delete, I am deleting a record on the source, which goes to the target, and I don't see that record because already the record is not there. That is again a conflict, right? No data found. If you don't have the conflict handling here, right? The CDR, conflict detection and resolution, that will throw an error, no data for 1403. And similarly, I have a delete statement here running, and that delete statement replicates to the target, and the before image of the delete statement and the current image which is present in the table are differing. So that again raises a conflict. It's a type of conflict. So these are all the pretty basic conflicts which are handled by the CDR. CDR is conflict detection and resolution. Yes, how conflicts are resolved. Till now we saw how what is Golden Gate, what is architecture of Golden Gate, different types of topologies, conflict management, different types of conflicts, and how the conflicts are resolved. So how the conflicts are resolved? Of course, timestamp column, right? Without the timestamp column, we cannot resolve the conflicts. Okay. So yes, we have timestamp column, but how it is getting resolved? We need to know, right? So we have timestamp column, right? In both the sides, we have change timestamp column on both the source and target tables. But how it is compared and which will be succeeding? So how it is done? So how it is getting resolved? Okay. For the resolve conflict for insert operation. So when the insert row exists in the target, I'm inserting a row in the source, and that row comes to the target, but already the same. For example, employee 100, right? I'm inserting a row with employee ID 100 in the source, and that row comes to the target, and already an employee ID with 100 exists in the target. So that we call it as insert row exists. So for that we have 4 options, which is nothing but override, ignore, discard, min or max. Min or max is nothing but use min, use max. We'll talk about it later. These are the 4 options available for the conflicts to get resolved. And next one is the update operation. For update, we do have 2 types. One is update row missing. That is what we talked about. And a row is getting updated at the source. The same row is not seen in the target. So what happens? So for that, we have 3 options: overwrite, ignore, discard. And similarly for update row exists, we have overwrite, ignore, discard, min and max, and delta. Delta is something very important whenever you use the CDR concept. We will be covering a later slide. Resolve conflict for delete operation. For delete operation, it is nothing but delete row missing, the same kind of whatever we have seen in the update, right? Update row missing and update row exists. The same thing, only the options differ here. For delete row missing, it is ignore and discard, and for the delete row exists, we can overwrite, we can either ignore or we can discard. So these are the three options available. So in a nutshell, as a global thing, right, this is how it looks like. These are all the resolve conflict resolution based on the timestamp available in CDR, right? The conflict detection and resolution. So now we have gone through all the parameters, prerequisites, requirements, and how to configure CDR. Everything is done. So this is how our extract parameter looks like. You can see two parameters here: the log all subcalls and run log options. Exclude tag to avoid the loopback, and get before calls to write the before image of the row whenever there is an update or delete operation is seen in the table. Okay. So this is how my our replicate looks like. For example, we have a rep error default exception, rep error default to append. So we have two rep error. One is with default and the other one is default to. So what does that mean actually? So whenever there is an error, whenever there is a conflict happens in this CDR, right? Whenever the error comes for this CDR, like for example, update no data found, right? 1403 no data found. When I'm updating a row in the source, that row is not there in the target, then it's a 1403 no data found. But that will be handled by the CDR itself. Okay. So for that, the record which is not present in this target side, right? That record, the before image of the record which comes from the source side, that will be written to the exception table. So this rep error default exception refers to the CDR, whatever we have configured. Apart from the CDR, the error which are encountered or faced by the replicate process, that is rep error default to append. So for example, I have some trial file corruption. So replicate appends. So that cannot be handled by the CDR, right? That's a data corruption issue. But this is something different, right? How to what data needs to be succeeded or what data needs to be replicated to the target or source in a bidirectional replication. So data corruption is something different. So for that, there is no way for the CDR to get resolve that particular issue, right? So when that error comes, it refers to rep error default to. So what happens? The replicate obviously appends. So that is the reason why we have two rep errors here. And this is the exceptions.prm is nothing but the exceptions parameter file. We call this as a macro here. Even we call it, this is the input param and this is the macro here, right? Exception underscore handler. So whenever there is an exception comes, this particular macro exception underscore handler comes into the picture and the record will be inserted to the exception table. And resolve conflict, we can see, compare calls and update all and delete all. Resolve conflict, insert row exists, update row exists, delete row exists, update row missing and delete row missing. For each and everything, we have different options specified by default. For insert row exists, use max, update, use min, and for delete row exists, overwrite, and discard, right? So let's see how it works. I don't want to confuse you in showing all these parameters. Let's see in a graphical way itself. So compare calls, it uses the before image of the trial record to compare with the current image. Default is by default. The resolution applies on all the columns. Whenever a conflict is detected and a resolution is made, the resolution is made on all the columns. Insert row exists with use max. Just leave about it. We will see in the next slide. Insert row exists with use max. Excuse me. So what happens when insert row exists with the use max, right? I have a new insert here, and you can see my salary is salary is 7,000 and the timestamp here, and in the target side already the row exists with the salary 5,000 and the timestamp you can see here. It's entirely different, right? It's 10 a.m. here. It's 10 a.m. here and it's 9 a.m. here. Let us consider this as a before image of the column, right? So what happens is like when this row record, right? When this record comes to the target, what happens? We used use max. The parameter we used is resolve conflict, insert row exists, default use max. So it means which timestamp is greater here. Just compare it. Here it is 10 a.m. and here it is 9 a.m. So 10 a.m. always wins, right? So that's a greater timestamp. So based on it, what happens? That particular insert will be converted to update and the record will be updated in the target. Now you can see both are in sync. This is how insert row exists with use max of timestamp works. Use max of timestamp in the sense it compares the timestamp for resolving the conflict. So update row exists with use min. So what happens? A record is getting updated in the source. The same we have the in the target side we have this kind of the same record for the employee table with different value, and I'm using resolve conflict update row exists default of use min, use minimum of change timestamp, right? So what happens like just compare the timestamp here. No, like we have this record got updated at 10:10:24 a.m. and here it is 10:10:30 a.m. Right, 30 seconds and 24 seconds. We have a difference of 6 seconds. So the minimum use min of change timestamp. This is the change timestamp, right? So use min of change timestamp is this is the least one. So this record wins actually. So what happens when this comes here? It updates the record based on the before image which comes from the source side. So that has the before image which comes from the source side, right? That has the minimum timestamp. So that wins. So that will get updated in the target. So delete row missing. What happens in the delete row missing is I'm deleting a row in the source side, okay, and in the target side I don't have that row. For example, I don't have that row in the target side. So the row got deleted in the source side. The delete statement is moved to the target side, replicated to the target side, but there is no row at all. So what happens? I have used in my parameter file rep conflict, resolve conflict, delete row missing, default discard. By default, what happens if the row does not exist in the target side? The row will be discarded to the discard file, and replicate will process the next upcoming transaction or record. Okay. So to see the stats, right? To monitor the CDR stats, replicate name, report CDR is the keyword here. So once you use this report CDR, you can see the CDR resolution succeeded, how many insert row exist conflicts happen, how many update row exist conflicts happen, and how many delete row exist missing conflicts happen. So this is how we need to monitor the CDR, how many conflicts occurred for that particular replicate process, right? For each and every table, it shows. Currently, we have only one table, so I got it for one table. If you have multiple tables, for each and every table, this report CDR shows there. So again, coming back to the parameter file, this is the extract parameter file for the CDR, and this is the target replicate parameter file for CDR. So for example, what happens? I have only one table, right? So for one table, I need to resolve for each and every conflict. I need to give the resolution manually, right? I need to tell the golden gate what needs to be done over there. When the insert row exists, what needs to be done? How you need to resolve that particular conflict. So for each and every conflict, I need to tell the golden gate what needs to be done. So this is for one table, right? What if I have n number of tables, right? If I see this parameter file, oh my God, you see so many parameters, right? So when you open the parameter file, no, definitely I will get faint like this for sure. Even though if you use macro or whatever it is, right? So definitely I will be fainted like this. So seeing for if I have 500 tables, for example, for each and every 500 tables, I need to tell the golden gate how to resolve the conflicts, right? We have 5 conflicts, and I want to mention all the 5 conflicts, resolution for the 5 conflicts for all the 500 tables. So that will be real tedious thing. So to overcome this, from 12.3 Golden Gate, Oracle has introduced Auto CDR. So let's see what is Auto CDR. The same again. Let's come back to the same thing. The same diagram. The same row is getting updated in the source and target, and what is needed to resolve the conflict here, right? So again, it's a timestamp column, but how Auto CDR handles it. So how it simplifies our work of managing the conflict and detecting the conflict and resolving the conflict, right? So it's a built-in CDR, and whenever okay, I'll just tell the important points here. It's a built-in CDR, and when you add this or enable this Auto CDR to any table, right, automatically the supplemental logging will be added. Okay, and another enhancement for this particular Auto CDR, right? We don't want to manually create any timestamp column in each and every table. Automatically, an invisible timestamp column will be created for the table which are configured for the replication, right? If I enable replication, I mean Auto CDR for any table, right? Automatically an invisible timestamp column will be created for that particular table. I will show you all these things in the slide. And the requirements, right? The minimum, either in source or target, wherever you use is Auto CDR, right? We need minimum version of Oracle database 12.2. If you have 12.1, Auto CDR will not work. Okay, that is enabled from 12.2. And it needs the integrated capture. Classic extract will not support. Why? Because as I told you, when you enable Auto CDR for a table, an invisible column automatically gets created or added. We need to capture the timestamp of that invisible column. Classic extract doesn't have that ability or capability to capture the values of the invisible columns, but integrated capture has that. So we can use only integrated extract. By default, integrated extract captures the values of the invisible columns. And in the target side, we need the integrated replicate or parallel replicate. Why? Because we have a special parameter called map invisible column that works only for the integrated replicate or parallel integrated replicate. Okay, and primary key is mandatory. Not only for the bidirectional replication, I would recommend for any golden gate replication for the table which is going to get configured for the replication, we need to have a primary key. So without the primary key, the data integrity is not confirmed or not guaranteed, right? That is what you will get a message where in the report file when you see a table doesn't have a unique key or primary key, right? So the configuration of auto CDR is very simple. You don't want to mention so many parameters like you have it in the manual CDR, right? So just add the parameter, map invisible columns in the replicate parameter file, and using the GG admin user, log into the database and execute this simple syntax. DBMS golden gate ADM dot add auto CDR. This is the schema name. Source is the schema name and employee is the table name. So when you execute this package along with this schema name and table name, automatically the CDR will get enabled. That means auto CDR will get enabled for that particular table. Let's see how it is. Okay. So what happens before that? I want to explain you what happens exactly in the background when an auto CDR is enabled. So automatically creates an invisible column. So I have an employee table here. I'm enabling the auto CDR for that. So what happens? And you can see an invisible column gets created or added to the employee table and creates a row level invisible column. This does not affect any application. This is invisible and it does not. Sometimes people may think this invisible column may affect my application, right? So by design, my application may work wrongly or something. No, nothing will happen to your application. So it doesn't affect your application at all. This column is automatically maintained by the CDR, okay, by the golden gate. And additionally, a tombstone table is created, a delete tombstone table we say, and this is also automatically maintained. I will let you know like what exactly the tombstone table is. And this is how we need to configure the auto CDR. Just I'm logging as sysdba, and I already have a user GG admin. Okay, I'm just creating a table, source.employee, and this is my table here. And table is created, and I'm just describing the table, and you can see employee ID, name, department, salary, country are my columns. So now I am going to enable auto CDR for this employee table. So before that, what I'm going to do is I'm going to check whether the main thing, right? We need to check whether supplemental logging is enabled. Add tran data, I showed you, right? We need to add the tran data for the employee table. So I'm just checking whether my tran data, the tran data is added for the employee table or not. No, it's not, right? Logging of supplemental read log data is disabled for the table source.employee. So now I'm going to execute the package for that source schema employee table. The package has been executed successfully. Auto CDR has been enabled for this particular table. And now I'm going to check my info tran data. And you can see supplemental log is enabled, right? I haven't issued add tran data, but automatically tran data has been enabled for all the columns. It will be enabled for all the columns of the table whenever you enable the auto CDR. So I'm just describing the table after enabling the auto CDR. I couldn't see the invisible column. To see the invisible column, you need to set specific parameter like a set. We need to set call invisible on, so that when I describe the table, you can see the invisible column here, right? We have at last this invisible column which has got automatically added to the table, and this is the tombstone table in the source schema. For that employee table, we have a tombstone table. I will let you know what is tombstone table. And auto CDR, when an insert happens, what happens? Like in an auto CDR, I have an employee table, I'm inserting a row, and you can see the row got inserted along with the current timestamp, right? When I insert a row along with the current timestamp, that current timestamp will be captured in the invisible timestamp column, right? That invisible timestamp plays a major role here, which helps to resolve the conflicts, detect the conflict and resolve the conflicts. Wherein in the manual CDR, we need to create or add the timestamp column for each and every table. Wherein here, once we enable the auto CDR, automatically for the table, the invisible column will be created or added. So when I update a record, automatically it populates the invisible column. See, you can see the timestamp is 1, and after updating the employee record, right, whose employee ID is unread, you can see the timestamp has automatically changed to T5. So for just example, instead of timestamp, I just gave T1 and T5. T5, it is the latest one, right? T5, it got updated to T5. And when I delete a record, automatically logs an entry in the delete tombstone table. It means like I'm deleting this record. The record will be deleted in the from the table. But what happens is like along with the primary key, the tombstone table has only 2 columns. One is the primary key of the table of the employee table and the timestamp of the deleter. Okay, the current timestamp when the delete operation is performed, right? So those two are there in the tombstone table. So these are the basic types of conflicts: insert conflict, update conflict, delete, delta resolution, insert, update, insert, delete, column group, piecewise, log conflict. So these are the various types of conflict. And in the CDR, we don't support insert, update conflict, insert, delete conflict, column group conflict, or even log is not compared in the CDR, manual CDR we say. But in auto CDR, everything is supported. So it means, like in comparison, I showed you, right, what are the supported data types. The log columns will not be compared, and resolution cannot be done for that particular log column whenever there is a conflict happens. So that cannot be done. So you need to exclude the log column. Wherein here in auto CDR, even the log columns also can be compared and resolved. So that is what an additional enhancement we see in the auto CDR. And let's see, like, what happens in the auto CDR. Update row missing. I'm updating a row in the source. So their salary is 7,000, and their employee, I'm just setting the salary is 7,000, their employee ID is 100, and in the target, I see that particular row does not exist, right? The source side, it got updated, it goes to the target side, and the row doesn't present in the target side. So it is update row missing. The row which is going to, it needs to get updated, it is missing in the target. So add auto CDR, it deletes. Here the major role is played by the delete tombstone table. So what happens is, like in the employee table, when the delete happens, it goes and refers the delete tombstone table, and it sees the timestamp here. Okay, and if you see the before the image of the timestamp here, right, it is greater than the image of the timestamp which is there in the tombstone table. So somewhere someone has deleted the record in the target side, but that didn't get replicated to the source side. So in that case, right, we cannot ignore or overwrite the record, right? We need to know what exactly the record should be in the target side. I mean, what should be the record in the target side, it needs to get replicated, right? So the timestamp in the row LCR is greater than the timestamp in the tombstone table. So the update is converted to insert, and the row is inserted to the target table. So that is what happens. That is a major role played by the update, delete tombstone table. So this we call it as insert update. What happens? The same thing. For example, if the record which is coming from the source has lesser timestamp or earlier timestamps when comparing to the timestamp which is there in the delete tombstone table. So what happens in that case? The update is discarded because the record has been recently deleted, right? We can see the timestamp in the delete tombstone table, which is T15, and timestamp in the record, which is T10, 10 and 15. So 15 is the latest timestamp. So recently the record has been deleted in the target side, which was not, for some reason, for some issue, it was not replicated. There was a delay and it didn't get replicated to the target. It is yet to get replicated. But before that, we saw this update coming in the, coming from the source to target. Okay, in that case, it compares the timestamp in the delete tombstone table and acts accordingly. So here the timestamp of the record, which is earlier when comparing to the timestamp in the delete tombstone table. So since the record is recently deleted, I don't want this record to get inserted in the target side. So the record is safely discarded. So delta conflict resolution, for example, what happens, like I have source and target table in the, my balance is 5,000, for example, my balance is 5,000, and I'm withdrawing in one side, I'm withdrawing 500 rupees. So my balance becomes 4,500. So that connection, right, the whatever connection I'm doing when withdrawing the money of 500 in the ATM machine, that goes to site 1. And within few seconds, I'm going to a different ATM, or I'm just depositing the amount of 1,000. That goes to a different site B. So for some reason, these two updates didn't come actually till now. The replication is running, but still these two updates didn't come to the database. I mean, from site A, the withdrawal of 500 didn't go to site B, and from site B, the deposit of 1,000 didn't go to the site A for some reason. So in that time, what happens? Update row exists. We can use either use minimum or use maximum. Both the things can be used. Either it is for in CDR, I'm saying in CDR, manual CDR, we can use either use minimum or use maximum. Use minimum of timestamp or use maximum of timestamp. If you use minimum of timestamp, 4,500 will be the balance. And if you use maximum of timestamp, we will have 6,000 as balance. But actual balance should be 5,500. This is the major reason we use delta conflict detection and resolution. And to enable the delta conflict detection and resolution, what we need to do is first, initially, we need to enable the auto CDR. This is a command which I showed you in the earlier slide. Along with that, we have another package. We need to give the in the schema name, we need to give the schema name, table name, and the column name, wherein you need to enable the delta CDR, delta conflict detection and resolution. Mostly these columns, right, we need to use it majorly in the balance or accounting or monetary columns, right? We have monetary columns, amount, balance. In such type of columns, we need to use this delta CDR. How to manage auto CDR? So tombstone table, right? If you do n number of deletes, so all the entries will be stored in the tombstone table. If I do 50 million deletes, all the 50 million deletes will be stored in the tombstone table. So on a day-to-day basis, the tombstone table will be keep on increasing, right? So we can do a purge of it. We can schedule. This is the package where we need to execute, or we can even use it in a cron tab and as a scheduled thing. So it can purge the tombstone table. And alter auto CDR, I can this tombstone delete, right? It is not mandatory like all the time. We need to whenever there is a delete, we need to record the delete in the tombstone table. So we can even make it as false. Okay, so whenever there is a delete, it will not record in the tombstone table. So that we need to enable it. By default, it is enabled. So if you if we are making it like true or false, we can change the configuration as well for the auto CDR. That is what the package here for changing the auto CDR configurations. This is alter auto CDR. And if you want to remove auto CDR for a table, then DBMS Golden Gate ADM remove auto CDR is the one which we need to use for removing the auto CDR. So CDR versus auto CDR is the one. This is the CDR replicate parameter file. In the left hand side, manual CDR, and the right hand side, if you see, it's very simplified. We have only the map statement. We don't have any compare calls or resolve conflict statements, which is handled automatically by the auto CDR. And this is the different manually configured parameters for the CDR. Only one command is enough to the auto CDR. More maintenance on the CDR, and for the auto CDR is less maintenance. Full control on CDR, right? We need to tell what kind of resolution has to be made for each and every conflict, but there is no control. I'll let you know what is this. I need additional 10 minutes so that I can complete the presentations because I have nearly 105 slides. Insert, update, delete conflict not supported because there is no tombstone table at all in the CDR. Wherein auto CDR, that is there. That is one of the major advantages we have. Column group conflict not supported. Column group conflicts are supported. Log comparison is not supported in the CDR, and in the auto CDR, yes, it is supported. And in the CDR, right, for each replicated table, we need to have timestamp column manually, right? We need to add the timestamp column, but wherein for the auto CDR, it is not required. So no control on CDR, right? Even though if you have so many advantages on the CDR, there is no control on CDR. Personally, I don't like much on the auto CDR, right? This is the major drawback. So we cannot control how the resolution needs to happen because it always uses the use max of timestamp. There is no override, there is no nothing. It always uses the use max of timestamp. Either it is insert row exists, update row missing, or whatever the conflicts the CDR is detecting, it needs to use only the use max of timestamp. Apart from that, it doesn't have any other option, right? So in this case, what happened? For example, I have an airline ticket reservation booking, right? One guy is booking from the phone, and the other guy is booking via system. So what happens in the guy who is booking from the phone goes to the site 1, and from the system it goes to the site 2, and his ticket has booked in the left hand side, right? Who is booking from the phone, his ticket has booked at 9:30 a.m. and who is booking from the system has booked at 9:31 a.m. So when this happens, the replication happens bidirectional. Which record wins? Obviously, right? The 9:31, the person who booked lately, right? He has the latest timestamp, and that wins. But this guy's ticket will get cancelled, right? So that is not the logic which needs to work for the airline ticket reservation. We cannot use auto CDR here, right? We need to use min of whichever has the least timestamp, that record should win here. But here, whichever has the highest timestamp, that record is winning, which is not acceptable. So that is one of the major drawback I told you, right? According to the auto CDR, the guy who booked via phone will be cancelled, and the guy who booked via system will get succeeded. But actually, the left hand side should succeed and the right hand side should fail. How to avoid conflicts? This is some of the major thing. Like for the conflicts, we need to have an application traffic router or a balancer. Why? Because for example, I have a bidirectional replication for a banking account application. So what I will be doing is I will be having a middle layer, which is nothing but our application traffic router or load balancer, and we can create a logic on either at the application level or at the application traffic, that layer you have, right? The hardware level. All the odd account number should come to site A, and all the even account number should come to site B. In this case, what happens? We can easily avoid updating the same row, right? Updating the same row on both the sides, right? We can avoid DML operations on same rows on both the sides. That can be avoided. And what's new in Oracle Database 21C for OGG? This is what by default auto CDR resolves. As I told you, only use max of timestamp, right? It uses the latest timestamp, and the record which has the latest timestamp wins. But From 21C, there is an enhancement. You could have seen my previous slide, right? I have given a slide, CDR versus auto CDR, Batman versus Superman. At the end of the movie, right? You guys have watched that movie. At the end of the movie, Superman will die. Actually, that is what. Even though auto CDR is a very good concept, it has been introduced by the Golden Gate, but we do have a lot of drawbacks of it, right? Like we don't have any control on that. So that is one of the major drawbacks we have it in the auto CDR. So by default, when they introduced from 12.3, only the latest timestamp wins in the auto CDR. We cannot control that. But from 21C, what they have done is they have included a couple of more options, which is earliest timestamp. I mean, use max, use min. So auto CDR uses only use max of timestamp. Now from 21C, what happens is it uses use min of timestamp as well. I mean, the earlier timestamp also can be used for resolving the conflicts and site priority based. It means whenever there is a conflict happening, only the site B wins. That is site priority. So those two options are coming to the auto CDR. So all these options are already available in CDR, but now they are enhancing. Let's see after the movie. Not sure if Batman versus Superman comes. I mean, part 2 comes, right? Superman may emerge again, and he can come to the movie as a superhero. So that is what I am also expecting from the auto CDR enhancements from 21C. And let's see what happens with the auto CDR for this. And if you want to know what are the other updates for the Golden Gate, for the database 21C, you can just click on this link. I have written an detailed article on this. I'm done and I'm fine for the questions. And so thanks for giving me an extra minutes, Chandan and AOG team. Thank you very much.
Yeah, thank you, Veera. Actually, there are many questions in the Q&A section. If you can take some of questions from there.
Sorry, excuse me. If app team says no timestamp column can be added in tables, in that case, can you please guide how we can enable CDR? Mayur Deshmukh. Yeah, we can enable, but you see, even in balance column also we can enable CDR. But always, right, if you want a perfect one, it is always better to have a timestamp column. So if app team is not accepting, then we cannot do anything, right? They want, that is what we need to sacrifice something, right? This is the prerequisites. If you're not going to follow the prerequisites, then we cannot enjoy the future, right? That is what. So we need to have a timestamp column for sure. The next question is Rakesh T. Hi Veera, say we are not using OGG tran data to add supplemental logging. Instead, we are using alter table, enable add supplemental log all columns, and say later we are adding a column to this table. Is it mandatory to drop and recreate the supplemental logging for the table? Yes, it is mandatory. Whenever there is a this actually a tricky one, right? So when you enable DDL replication and when you add tran data, right, then automatically it comes. But when you don't enable DDL replication, then it's not possible. For this purpose only, what happened is Oracle introduced schema tran data, right? When you enable, even though if you don't have DDL replication in place, and if you enable tran data, the schema level, schema tran data, so whenever you add a column to the table or whenever you drop a column to the from the table or whenever you modify the columns, no problem at all. That will be automatically taken care by the schema tran data. So it is always advised to use the schema tran data instead of using say tran data for each individual table. Log all subcalls. Let me see what are. So I keep on getting the questions actually. Before reading it, it's getting scrolled out. When there is a column change on a table in terms of bidirectional, how it should be handled. When there is a column change on a table in terms of bidirectional, how it should be handled. Basically, DDL replication. With DDL replication, it is asked by Ashish. Basically, DDL replication is not recommended for the bidirectional replication. So we have a concept called trusted source. So in any two-side model, one side will be always trusted. Whenever there is a data integrity issue, application teams says that only from site 1 is my trusted source. So the data which is there in site 1 is the correct one. In that case, in bidirectional replication, we can do a DDL operation, but it should be done only in one side, not on both the sides. If you enable DDL replication, it should be done only on one side, not on both the sides. And if you don't enable DDL replication, you need to get a downtime for that particular table. For whatever table I'm going to do a DDL replication, right? That particular table should not have any DML operations during the DDL change. Okay, if that particular table has DML changes, when I am altering the column or modifying the particular table, what happens is like that leads to the replicate to abandon. So you need to get a downtime for the particular table, or whenever in a tech window you can easily do the. I would recommend you do the DDL changes only in the tech window. So that will be a safer side for a bidirectional replication having this DDL changes. And Mayur, can we have exception table for each and every tables involved in replication? Yes, we can have, right? We have a dedicated exception table. We can have it, or we can have global exception table. Both the things are possible here. So, do we have any additional time, Chandan? Or I think so. I have so many questions, but definitely you can ask all the questions in Twitter or in LinkedIn, or even you can even email me. Or it's better way, like you can post the questions in OTN
Yes,
forum.
Vira.
I would really encourage that. So if you post the questions in the OTN forums, right, the entire world watches it, right? So whoever from the any corner of the world, if they have some issues and they do a Google, the forum comes up front in the page, right? So even they will get benefit of it. So I
Yes, Vira, we
recommend.
can take a question offline actually,
Yeah.
and we will mail you all the questions and you can answer it, and that answers can be uploaded on the website.
Okay.
So yeah, we have very time constraint today, and uh, we need to move forward. So thank you, Vida, for joining us today and sharing your knowledge with us. I want to encourage all participants to provide feedback about this session. You can scan this QR code and put, or you can use the bit.ly link to get the survey link and provide your feedback. Also, do tweet on Twitter to make some noise about today's AIoT webinar, and to you can thank our speakers. So by this way, you can connect with the speaker participant directly and do some networking with this. So thank you very much. And next, I have some announcement. We have very knowledgeable webinar are lined up in upcoming Wednesdays. So go to the AIOG website and must register for it. Attending live webinar is totally free for everyone. So please do spread a word about the same. And at last, thank you all for joining us, and keep this momentum of learning new stuff in this new year. So thank you very much for joining us. Thank you, Veera.
Okay. Thank you,
Thank you
everyone,
all.
and thanks, Leo. Yeah, thank you, everyone.